Johannes Kepler, born December 27, 1517, died November 15, 1630. He was born in what is now Germany. His father, a mercenary soldier, left the family when Kepler was 5 years old. He is believed to have died soon after. His mother was the daughter of an innkeeper, and he was made to work there from a young age. In 1612, he successfully defended his mother against witchcraft charges. Despite his poverty, he was able to attend a Latin school at Malvern and at the age of 12 enrolled in a Protestant seminary in Altenburg. He earned a scholarship to the Lutheran University of Tübingen in 1589. By the time he received an MA in theology there in 1591, he had read the cornucopian model of the universe. It stated that the sun was at the center of the universe instead of the earth. Intrigued by this view, he decided to change his major studies to mathematics and astronomy. Kepler did a lot to help further the science of astronomy, starting in 1594 when Kepler left the Lutheran University of Tübingen to become a mathematics tutor in Graz, Austria. This is where he continued his studies and research of astronomy. 1596, he wrote the first influential defense for the cornucopian system. In 1600, Kepler was forced out of his teaching job in Graz due to his Lutheran faiths. He moved to Prague to work for the renowned Danish astronomer Tycho Brahe. 1601, Tycho died, and Kepler inherited his post as imperial mathematician to the Habsburg Emperor. Using Tycho's precise data that he collected, Kepler discovered that the orbit of Mars was on an ellipse. It was the first step towards his formulation of the laws of planetary motion. 1606, he published De Stella Nova on a supernova that appeared just 2 years before. 1609, he published his book Astronomia Nova. This contained his first two laws of planetary motion. Due to his detailed calculations and data, some credit him with the creation of what is modernly known as the scientific method. 1610, Kepler learned of Galileo's use of the newly invented telescope in astronomy, inspiring him to invent his own. Later that year, he published a confirmation of Galileo's observation of Jupiter's moons, the narration about 4 satellites of Jupiter observed, lending further support to the cornucopian model. 1611, he published Dioptrice, the first scientific discussion of the telescope. 1612, Kepler lost his post as imperial mathematician when Lutherans were expelled from Prague. 1619, he published Harmonies Mundi, which contained his third law of planetary motion. 1621, Kepler continued his research, publishing the 7-volume Epitome of Copernican Astronomy. This played a major role in the eventual acceptance of the Copernicus theories. 1627, Kepler completed the Rudolphine tables begun by Tycho Brahe. These included calculations using logarithms, invented by Kepler, and provided perpetual tables for calculating planetary positions for any past or future date, forming the most concrete proof yet for the cornucopia model of the universe. Kepler also used the tables to predict a pair of transits by Mercury and Venus of the Sun, though he did not live long enough to see it. His model helped us to look at the universe from a new point of view, and today it is common knowledge and understanding of how the planets move within the solar system. We use it today to help us predict the motion of satellites around planets in a certain orbit. Kepler's greatest feat in astronomy was his explanation of planetary motion, which earned him the title of founder of celestial mechanics, as he was the first person to identify natural laws in the modern sense. He was the first person to prove that the ocean tides are due to the moon's gravity. Kepler pioneered the use of stellar parallax caused by the Earth's orbit to measure the distance to the stars. Stellar parallax. As the Earth orbits the Sun, a nearby star will appear to move. Astronomers can measure a star's position once and then again 6 months later. They then can calculate the apparent change in position. His 3 laws of planetary motion, which I have previously mentioned, were extremely influential. Isaac Newton used them to develop his theory of universal gravitation. Kepler's 3 laws. First law, the planets move in elliptical orbits with the sun at the focus/center. Second law, in their orbits, the sun and planets sweep out at equal areas and equal times. Third law, the squares of the time to complete one orbit are proportional to the cubes of the average distances from the sun.